So the second part of 2.4 is introducing the idea of a complex number. So up to this point, you guys have really only dealt with the real number system. And now we're going to just touch on the complex number system. We will spend a lot more time on this as we progress through secondary two. But just so you understand, like there is the idea or the complex number system. And so when I look at the complex number system, there is our x-axis, which we usually call our x-axis, is like our real numbers. And then we have our complex number system, which we usually is our vertical one. So this is our complex, or our imaginary, I should say. And the combination of the two makes up a complex number. So when we look at a complex number, they're written in the form a plus bi. Now, every number is considered to be a complex number. It's just the imaginary part is not there, and so we just have the real part. And so as we look, a is the real part of the complex number, and the bi part is the imaginary part. So when I graph a point in the imaginary or in the complex number system, I'm going over, right or left to the real part, and then up or down. So if I had a plus bi, I'm going to go over a spaces, and I'm going to go up b spaces. And so this point right here would be the point a plus bi. I'm just going to call that b. All right. So, but it's the imaginary number system, so there's our bi. When we add or subtract complex numbers, we just combine like terms. So what I mean by that is we combine the real part with the real part and the imaginary part with the imaginary part. So it's not a big deal. Like if I was doing, let me see that again. If I was doing a problem, something like 2 plus 3i, and I'm adding or subtracting, I'll just do an addition problem, 6 minus 4i, then I combine like terms. So 2 plus 6 is 8 because that's the real part. So these are both the real parts. And then I'm going to do our imaginary part. So 3i plus negative 4i, which is going to give us our negative 1i. And so my answer then would be 8 minus I. The other thing, and the reason why I even have the complex number is because I need to deal with taking the square root of a negative 1. And if we put the square root of negative 1 in our calculator, notice what happens. If I take the square root of negative 1, and I think you guys have seen this a little bit, if I take the square root of negative, I need a negative sign. So negative 1, notice how it gives me an error. If I go to the go to part, what it's going to tell me is that I can't take the square root of a negative. I can't take the square root of any negative number. I can take or change this to be negative 15, and it's still going to give me an error. I can't take the square root of a negative, and that is an issue. And so the way that mathematicians a long time ago came up with a way to fix that is the idea that the square root is the square root of negative 1 is I. And so if we think of I squared, that means the square root times the square root. Remember, we square something to get rid of the square root sign. So I squared is equal to negative 1. And we're going to use that as we progress through this unit, and we're multiplying complex numbers. So the way we're going to use this with simplifying is that very first thing is I always look at the negative 25 as a negative 1 times 25. So as I look at this, I'm saying, okay, it's a negative number. So this is negative 1 times 25. I know as my first step then that this, because I have a negative 1 here, this leads to an I. So I've got an I term. If I'm breaking down 25, then I'm going to take that 25 and I'm going to figure out what times what's 25. So this is 5 times 5. Because it's 25 and I've broke it down, this is no longer here. And now I do the same thing. There's really an imaginary 2 sitting here, so I need a pair. I have a pair of 5s, so it's going to go on the outside, and an I always comes on the outside. So in this case, I have nothing left over, and so this is my answer. When I look at example 5, this same idea is going to play out. So I look at my number. It's going to be a -1 times 16. Again, the -1 automatically leads me to an I. I'm going to break down the 16. So this is 4 times 4. And so I've broken down 16 so I can cross it off. I can break down the 4 times 4 again, but notice that you already have a pair here. So I'm just going to leave it, because remember the idea is whatever's sitting on the shelf, that's what I need 2 of a kind of. So I've got 2 sitting on that shelf, so I only need 2 of a kind. So when I look at my letters, I've got 3 A's, 4 B's. And I'm going to break this down for you, but just remember what I just said. Okay, so the 4s are going to go down further. And then as I look, because there's an imaginary 2 sitting here, I'm looking for groups of 2. So I have a group of A's, a group of B's, a group of B's, a group of 2s, and a group of 2s. So now I'm going to pull everything out that I have a group of 2. So I've got a group of 2s here. I'm going to pull it out. I have a group of 2s here. Going to pull it out. Group of A's, group of B's, group of B's. I have this I that I need to take care of because it's always going on the outside of the radical. Okay, so we took care of this, and the only thing that's left over is this A. So it's going to stay underneath. So when I simplify all of this, I've got 2 times 2, which is 4, A, B squared, I, and then the square root of A left over. And this is my answer. Again, we only have an I is if you have a negative underneath our square root sign. So as I look at this next problem, again, the -7 out here does not produce an I. It's just a number that's on the outside. When I look at the -72, I'm going to go -1 times 72. I'm going to break down the 72. We can break down the 72 however you choose to. If I want to remember that this is 8 times 9, great. If I don't know that, I can do 6 times 12. If I don't know that, I can do 2 times 36 and go from there. So remember that the key here is that we're breaking it down as far as we can. So 72 goes down, 8 goes down, 4 goes down. When I come over, 9 goes down. Okay, I have 3 X's, I have 4 Y's, and I'm looking to see what's sitting on the shelf because there's nothing here. There's really a 2. And now we're going to look for our groups. So this -1 again is equal to an I. I have a pair of 2s, however you want to do it. I could do here, or I could have gone here. It doesn't matter. Pair of 3s. They don't need to be next to each other. They just need to be one of your factors. You have a pair of X's, a pair of Y's, a pair of Y's. And then what we need to remember is that we have this -7 that's already sitting out there. So -7 is already out. And now I have a group of 2s. I have a group of 3s. I have a group of X's, a group of Y's, a group of Y's. And I have this I that I need to take care of. And then I have a 2 that isn't paired with anything and an X that isn't paired with anything. So it's going to stay underneath the radical. So now as I simplify that, I'm going to multiply the numbers on the outside. And so as I do that, I've got -7 times 2 times 3, which is going to give us a -42. And then I have X, Y squared. The I is on the outside of the radical. And then you have root 2x left over. And then we have our last problem, which is an example of the addition or subtraction of a complex number. Remember, we talked about how we're just combining like terms. So when I look at like terms, I have 3 minus 5. If you want to group it together, fine. If you don't, that's fine as well. Okay, so I know that I've got 3 minus 5 that's grouped together. And then you have your negative 2i and 8i. So if I'm subtracting, and again, if you want to distribute that negative sign like we did with polynomials, you can. So this is like a negative 1 times 5, which is negative 5, and negative 1 times 8, which is negative 8i. And so then we're adding. So 3 subtract 5 is negative 2, and negative 2 subtract 8 is negative 10. And so this would be my answer. If you have any questions, make sure you ask. And that's it.